Thanks for being here. My name is Kevin, and I'm a software engineer at RStudio. And today we're going to talk about, well, what it says on there, right? Streamlining AI, prototyping, and deployment with R and MLflow. So usually with when you submit a talk to a conference, it's usually like 6 months before the event, and then a week or two, and then you sort of just like forget about it. And then a week or two before your talk, you look at the abstract that you submitted, and then put a talk together. And then I was like, did I really put AI on there? And it's like for a long time I can't say AI with a straight face. It's always like, oh, yeah, I'm implementing some AI solutions. It's like it's kind of like how big data was a few years ago before it was like mainstream and like before Spark got really popular. So now when I say, oh, I'm well versed in AI, I feel like I'm trying to trick someone into giving me money. I don't know if you guys get that. But we'll talk a little bit about AI, some deep learning. Tensors are flowing. It's cool. And so today we'll do a quick update on the R ecosystem for AI stuff, because you can't deploy or prototype AI stuff without the underlying tool set, and do a real quick recap of MLflow, and do a demo to make the concepts more concrete. So a quick update on Spark+AI, which is an interface for Apache Spark in R that is, I guess, more opinionated than Spark R. It's more integrated with the tidyverse, if you're familiar with that. And some of the recent developments include the Apache Arrow integration to speed up user-defined functions, and also XGBoost integration. And now you can also read and write TensorFlow TF record files that we'll actually utilize in a bit. And if you're into NLP, we're also implementing Spark NLP, the R interface for that. So I personally think deep learning is super cool. It's not directly applicable to everyone's jobs right now. And sometimes I even say, even if you don't need it, you should go give it a shot. So I was talking to my colleagues about, hey, what are some recent updates you want to give the folks here on the TensorFlow developments in R? And this German colleague of mine sent me this picture of a hamster. I was like, I can't read that. Any Germans here that can read? Okay. So now I use my phone. I got Google Lens. Actually, it was the first time I used it. It was like super cool. And I was, oh, this is deep learning, right? I was like, oh, well, I don't get it. But just like it's like you got all this cool technology, but just be really skeptical of what's really going to drive impact, for the lack of a better term, in your problems. But anyway, so if you're not familiar with the R ecosystem for TensorFlow, right now we have feature parity with the Python interface. So basically any deep learning stuff you want to do with TensorFlow and Keras, you can also do in R. And we're sort of on board right now with Google's decision to embrace TF Keras as the main entry point for building models. And there's also a work in progress package to enable probabilistic modeling with the TF probability package. And eager execution is supported, and we're also preparing for the 2.0 release later this year. All right, so let's talk about MLflow now. So a quick recap. This is probably not the first talk you've seen at this conference on MLflow, but it's an open source platform for doing a few things. So you can do experiment instrumentation, basically tracking your experiments. And it also enables you to package up your scripts into what are called projects, so they can be run in a reproducible way across different platforms. And then there's also a model deployment mechanism. That's basically a convention to specify models, and then also the toolkit associated to actually deploy those models. And you can use each of these separately, or you can use them together to build an end-to-end workflow. So the tracking API, again, really just helps you keep track of stuff. So a big part of building a machine learning model is iterating through the different hyperparameters or network architectures. And if you're sort of jumping into it, you might try different, say, dropout values, different number of hidden units, and you might like figure out a path forward. So for example, this learning rate works really well, so then you start tweaking other things, and then 20, 30 minutes in, your results start getting worse, and then you're like, oh, what did I do like half an hour ago, right? So if you don't have a systematic way to keep track, then that might be problematic, right? So you can use source control, but we feel like this is a better way to go about it. And projects, like I mentioned before, it's basically a convention to specify your dependencies to run a training run or an experiment. And we'll talk more about this later. And once you have the models, once you're done training the models, you want to deploy them. MLflow then offers a way to, again, specify the dependencies for these models, and then also provide mechanisms to deploy these models on common deployment targets. So things like Azure ML and whatnot. Okay, so let's do a demo, and hopefully it's going to make a lot more sense. And while we do that, we can also talk about some of the underlying technology. So how's the font? Good. All right. Okay. So let's back up a little bit. I should have gotten a slide here. So what we want to do is we're going to classify some flowers, our favorite massive distributed data set, Iris. Yeah. And we're going to use Spark to do some data pre-processing. So just imagine you got some data in your data lake, right? You're using Spark to do some data pre-processing, and then we're going to write the resulting processed data set into TensorFlow TF record files. Has anyone worked with TensorFlow TF record files at all? Okay. So it's basically a binary, the preferred storage formats for data for training TensorFlow models. So we'll do that. That's sort of like your ETL data prep step. And then once we have that, we can have another entry point to the project that's going to take that data and then train a simple neural network on it. And then once we have that model, we will be able to deploy it. So that's sort of what we're going to do in the next few minutes. Okay, so we're walking through this script, and actually I'm not going to execute these interactively. I'm going to talk through what the commands here do. and then we're going to use MLflow to actually run this script. So here we're making a connection to our massive cluster, which is my little laptop right here. And we're going to create some temp directories to write our data to. And of course, our data. And with the tracking functionality of MLflow, you can basically keep track of anything you want. So you can really track arbitrary data from text to images to data sets. So here we're going to say, OK, we're going to log this parameter. Let's call our data set. We're going to say, OK, that's the iris data set. And then now we're going to create a Spark ML pipeline. And then what we're going to do is we are going to take our iris data set, and let's just, for those of us who aren't too familiar with it, it's basically each column. We got 4 different predictor variables, so the different measurements of your flower, and then also the response, which is the species column, and then we're trying to predict the species. And then what we're doing here is, so this is like typical Spark ML stuff. We want to index the response variable. So then we're going to have Sato's that's going to be mapped to 0, and then the other ones to 1 and 2. And then you do vector assembler. That's also standard Spark ML, because you need all of your predictors to be numeric and in one column. And then each element of each row is going to represent an array of your numeric predictors. And since we're going to feed this into a neural net, we want to scale our features. OK, so we have a pipeline, and then once we do that, before we do that, we want to make sure we have a train validation split, so we don't cheat when we calculate our performance metrics. And then we're going to fit this pipeline on our training data set. And then once we have our pipeline model, we can transform both the training data set and the validation data set, and then write out TF record files. So here again, we're writing to local machine, but you can write it in a distributed way into HDFS, and at training time, you can basically do distributed training. So once we've done that, we're going to use a tracking API again to log these data sets. And these data sets will be used in the next step of our workflow. So here we did a couple examples of just logging stuff. We did some binary data. We also just did some just regular key value pairs. So we'll do that, and then the next step is going to be the model training step of our workflow. So here we specify a few parameters, and by using the MLflow param function, it exposes these parameters to the ML Run mechanism. So then when you actually do MLflow Run, you can pass these parameters to override any default values. So for example, here we have a number of units. This is 32 by default if you don't specify it. And we're going to train for 100 epochs unless you tell it to otherwise. OK, so then we have some helper function. This is not important at all, to parse the TF record file. So we'll do that, and then so now we have our training data set and validation data set. And then here we're going to just do a super simple feed-forward neural net in Keras to predict the class of the flowers. So we see that things like the number of units of that hidden layer and the learning rate. These are going back up. These are the parameters that you can specify. And we're going to train the model and save the results, evaluate the model on the validation data sets, keep track of that, and also save the model. So we just defined basically 2 steps of our workflow, and now we're going to actually run it. So we can do MLflow Run, and then we provide the entry point, and here an entry point can just be an R script. And the cool thing here is that here we're using the R interface to run this script, but you don't have to use the R interface. You can use Python, or you can use the command line interface. So someone without any knowledge of how you implemented your pipeline in R can reproduce your results. All right, so we have that. And then let's take a look at the MLflow UI. So we see that, let's check out what was captured. So you got the typical metadata. You got your date, how long it was run for, the entry point, and then the run command that I actually executed. And of course, our data set iris key value pair. And we have some artifacts that we log, and these are the data that we're going to be using in the next workflow step. Okay, so going back. We are going to do some interrogation of our experiment. So the way that we've designed the interface is meant to work with the tools that you're familiar with to manipulate data frames. So everything that's returned to you is going to be a table. So for example, in this run info, we can see, for example, the run ID, the source name, who executed this. So you can use the UI that we just saw, the web interface to look at stuff, but you can also do it programmatically if you wish. Okay, so what we're going to do next is ask this run where the artifacts are, and then we're going to pass these artifacts to the next step, which is the model training. So we'll do that. So again, the implementation of these steps are sort of abstracted away from the user that's executing these projects or runs. So then you can have people with using different languages and different skill sets work on different parts of the workflow and tie them together at the end. So in this case, we see that we keep track of the different parameters and metrics that we were interested in. And then we also have a little chart that shows how our accuracy and training loss evolve through the different epochs. And we also have this ML model artifact that specifies what environment is going to be needed to actually deploy this model. Okay, so let's go back to our session. And now if we do for example MLflow list run infos, we should see that we have two things that will run, and again you can inspect them here, or you can look at the UI. And then once we have the model, we can serve it. So let's do that. Okay, so now we see that this model is being served at this predict endpoint. So we can, I have this prepared, and we can basically post some information to this endpoint that's exposing this Keras model, and hopefully it's going to give us some results. So these would be like the class. I wonder if I can make this smaller. So these would be like the class probabilities. We can tweak these values. So just double check that they've changed. So the first one was a 5% chance, and then I can do JSON. Okay, there we go. So then like if we have a really long petal, then we're probably that third species, whatever that was. Okay, so let's go back to the presentation. So the things that we're gonna tackle next, if you've used R for a while, you probably know that dependency management is sort of an open problem. So for Python, Conda basically gets it right. But what do we do about R, like tracking R dependencies? So for a while, we have been using packrat, which basically keeps the sources of your packages. It sort of assumes that you might not have access to the internet, and then you'll compile and build on the fly when you want to run a new project. So how are we going to handle this? So we're working on a new package called renv that's going to it's more lightweight, it's more robust, and it's going to replace packrat as the preferred dependency management, I guess, a mechanism for our projects. And it's also going to be able to handle Python dependencies, because a lot of models built today that are built using like TensorFlow and Keras, which actually depend on the underlying Python library. So we also want to capture that. But if you run into stuff like Java, RJava, anyone familiar with RJava? Trying to set it up on Windows, it takes a weekend maybe. So these are still like the things we have to think through, but as a very last fallback, we can always just use Docker. And then another question that we'll get is, well, why should we use MLflow and not something else? And if you've been to some of the talks, you sort of see that there's not too many alternatives unless you're Facebook or Uber and whatnot. And as package maintainers, we are also asking this question. So MLflow was released. Well, it was announced at the Spark Summit in Europe about 6 months ago. And at that time, we were like, okay, we can provide this package. We'll see how it goes. We haven't really publicized it that much. But now we feel like it's mature enough that we can really just justify the investment into it and then get users on board. So roadmap for the R API, we want to provide better integration with deployment technologies. So right now, the tracking API is pretty much at parity with the rest of the languages. And the next steps are basically to tie existing deployment mechanisms. So for example, MLeap to do real-time scoring of Spark ML pipeline models. So we want to make that as seamless as possible. And also same for H2O and TensorFlow. And then we also have like arbitrary R models. You download some random package off of CRAN, and it happens to be the best results you get, and you want to deploy that. We will also have a way forward there. And if you're using some other machine learning library, and you really want to have a way to do that with MLflow, let us know or send a PR. So I'll leave you with some resources to check out. So we got the MLflow official docs, the GitHub repo, and if you want to try out the TensorFlow and Spark interfaces, there's some good information there. And then today's demo will be hosted at that GitHub repo. And I think these will all be uploaded along with the video to the Spark website. Okay, so I think that's a wrap. So I think we have enough time for a few questions. Thank you. Yeah.
Just a quick question. So you were running MLflow locally on your machine, basically, but if you were running in Databricks, is it pretty seamless to, within RStudio?
So we have we implement different, the way we do is we have different clients. So what I just demoed was like a local file client, but we also have a Databricks client. So then it's going to extract the relevant credentials, and then it's going to run on Databricks just fine. Yep. So question was, do you have to run the projects inside RStudio, or you can run it outside of RStudio? Is that accurate?
So like when you're developing it, do you kind of develop your workflow and your model and then just go back and wrap it with all the MLflow, or do you still kind of develop at a separate time with the MLflow?
Oh, okay. Yeah, let me try to answer that, and you can tell me if that answered the question. So basically, here I have sort of the completed workflow that I was executing. But then in practice, what you're doing is you're still executing line by line to see if you're coming up with the right results. So you might start an experiment run, and then you might start logging stuff, and then you'll confirm that what you asked it to log actually got logged. And then it's an iterative process, so you do that. And then once you have that, you can wrap it into a project. But in development, you're not bound to this mechanism to execute stuff. So the idea is that we want to be as not intrusive as possible. So you maintain your existing workflow, and then you explicitly say what you want to log. An alternative way might be to sort of have you not change your code at all, and we try to infer stuff from assignments and whatnot. But I think this explicit way, you add a few lines of code, but you have like full control over it. And then also along those lines, if you log a run, and then now you took a long time to go through a script because you were debugging, and then the duration for that run turns out to be like 30 minutes instead of like 30 seconds, and that might throw you off. But then we have a full set of functions to manage experiments and runs. So you can always just delete the prototyping parts, or you can organize them in a like a prototyping experiment, so they won't get aggregated into any performance metrics that you look at later. Does that kind of answer the question? Anything else? Can we do a quick poll? How many people here use R? Okay. This is probably all the R users in the conference. We don't get as much love at general tech conferences, but it's cool. It's cool. We love you guys.
But I was glad to see the RStudio booth. As soon as I saw that in the first floor, I was excited.
Yeah. So yeah, we have a booth. You can grab some stickers. It's great. Yeah. Question? You wanna?
Sure. So you got the Python world, you got pandas data frames hooking up with Spark data frames, and repeating the question is, do you think tidyverse will follow suit with that?
Pandas data frames and Spark data frames?
Like tidyverse Tibble data frames being interoperable with Spark.
Oh,
data
okay.
frames.
All right. So basically, when we're working with Spark using Spark+AI, the Spark data frames are actually implemented as Tibbles. So that's why I guess I didn't demonstrate it here, but if you're familiar with like dplyr and you have a Spark data frame in Spark+AI, the dplyr verbs get translated just like if you were using like MySQL or Postgres. They get translated to Spark SQL and then get pushed down to the Catalyst optimizer. So it's basically as if you were working in a local data frame, but everything is lazy. That's really the only difference.
Cool. Thank you.
All right. Thank you all.